In part two of this lesson, we're going to be talking about this thing called a z-score. And a z-score is how many standard deviations a piece of data is away from the mean. So previously, we were looking at data that fell, right on either one or two standard deviations above, below, even up to three. Well, sometimes data is not nice like that. Sometimes it falls between one and two standard deviations. Maybe it falls about 1.5 standard deviations above the mean. The z-score for that would be 1.5. So a z-score just tells us how many standard deviations that data is away from the mean. A z-score that's positive indicates that the data is to the right of the mean, and a z-score that's negative indicates that the data is to the left of the mean. There's a formula that you can use to figure this out. So what we're going to do here is take x minus x bar all over standard deviation. Another way of writing x bar, now that's a sample mean. The population mean would be the Greek letter mu, so you could write it like this as well, where x is the data piece, or the piece of data. And then the little u looking thing there, mu, is the mean. And then you just divide that by whatever the standard deviation is, and that's this piece right here. If you do this in your calculator, remember that you'll have to use parentheses around that numerator. You want to group those numerator together. Let's see how this happens in an actual example here. So we've got example 3 where the IQ test scores are normally distributed. That's good for us to know. We can use standard deviation now, with a mean of 102 and a standard deviation of 19. So those pieces of information are going to be important. The mean is 102. I'm just going to write that down to highlight it. And there's a standard deviation of 19. An individual's IQ score is found to be 124. So that's your X, or your data value right there. Okay. And it says find the z-score corresponding to this value. Now, if we think about this, if we were to draw a normal model, kind of bell-shaped like this, symmetric, right in the middle, we'd have the mean. That'd be 102. And then we'd have to go up one standard deviation. So it'd be 102 plus 19, which is 121. And then we would go up another standard deviation. So that would be 140. You do 121 plus 19. And unfortunately, our data piece here, our data point doesn't fall exactly on one of those. So actually that data point falls kind of right in here. So that would correspond to about 124. Now you might be thinking about this going, well, that's between one standard deviation to the right and two. You're right. And we want to figure out exactly how many standard deviations we are to the right of the mean. That's the z-score. So we're expecting our z-score to be somewhere between 1 and 2, probably closer to 1. To find your z-score, you can use the formula we just talked about, which is our data piece minus the mean, that's 102. And then you can divide that by the standard deviation, which is 19. If you type this into your calculator, what you're going to want to do is you're going to want to do 124 in parentheses. So we'll do a left parenthesis, 124 minus 102, close that parenthesis up, and then divide it by 19. Alternatively, you can just do 124 minus 102, hit enter, and then hit the division key, which will bring your answer down, and then just divide by 19. And you can hit enter, and you'll get your score there. So the z-score is approximately 1.158. And all that z-score is telling us is how many standard deviations away from the mean is the particular piece of data that we're looking at. Exactly where we expected it to be, Make sure you're doing that. Make sure you're checking the reasonableness of your answer. For instance, if I did not use parentheses when I type this in my calculator, I'm going to try that right now. Here's what your calculator will give you. It'll give you 118.6. Well, 118.6, 118 standard deviations to the right would be way down there. That doesn't make any sense at all. Anytime you math, especially in statistics or any other thing that you do, make sure you're checking the reasonableness of your answer.